Now that we've had a chance to jump into this world of cloud and start talking about our cloud principles and design, we're going to move into chapter two. And chapter two is around the networking and storage. So when you're talking about cloud and you're talking about, the needs to replace the things that we had in our data centers, there's usually big four that we talk about. We talk about compute, we talk about storage, we talk about networking, and then sometimes we talk about the services such as database services in here. So we're kind of jumping into chapter two, and we're going to focus on two areas here, including our cloud networking and storage. So first things first, what we'll be talking about here are identify cloud networking concepts, including connectivity types, common access types, software defined networking or SDN. And then we're going to focus on identifying cloud storage technologies, including storage features, storage characteristics, and storage types. So now take a minute and read the introduction on page 35. Go ahead and hit pause now and read that introduction. Okay, so now that you're back, you may have been shocked to find out that virtualization and the hypervisor, the technologies, have been around for over 30 years. But there was not a lot of things that people could do with them. Now, inside data centers, they would splice up disk, use it for some compute, and then for the most part, a lot of people are using virtualization at desktop level. Some people would get a Mac and then partition part of it so that they could run a Windows machine on top of a Mac machine. And so a lot of it was just playing around, and then it had some business capabilities. People might use virtualization on their own computer in order to create an environment that did certain things. Maybe they were replicating a test environment, or maybe they were creating a virtual machine on their own computer so that they could run things independently. But a lot of it still was in the testing realm, not necessarily things that we were building and using for production. So it's kind of interesting when you think this technology was sitting around for 30 years, waiting for somebody to figure out how to really, really take advantage of it. Well, it wasn't just waiting for people to come up with ideas and ways to take advantage of this. We also had to wait for our internet access and the speed and our networking and to get fiber out there in the environment in order to make things work fast enough to make this world of cloud exist. So that's one of the reasons, one of the first things we're going to talk about is the networking. And it's because we required a whole lot of things out here in the world in order to make cloud work. And also, when you think about it, cloud doesn't work without any of those networking components. So that is the introduction to our chapter two. And then, you need all of these chapters build on each other. But for sure, in chapter one, we want to be thinking about what we learned about the hypervisor and the virtualization layers and what it took to actually make cloud computing possible. And this is step one in order for us to come in and start provisioning cloud resources for the real world. So now that we've discussed the things that had to happen in our network, i.e. our internet, we needed the speed there in order for these things to work. And so some of the reasons here and some of the questions that we want to think about is like, how do cloud users access virtualized cloud resources? Well, of course, you can have connections directly into your data center, and we'll talk about some of these later in this chapter. There are ways to set up specialized telephony solutions, networking, those types of backbones, but we also have to remember that a lot of what we're trying to do is access things via the internet. So we have to make sure that our internet connections are good. And again, this is one reason it took 30 years for this technology, even though people understood how it worked, to really find a use case and a way to use this. And then also why do we want to use virtualized servers? Well, we've been through that quite a few times as well already, and we'll definitely talk about that a lot more. But we do it because it prevents us from having to order equipment and take months and months to put it in place, but we can create these virtualized servers out in a CSP and instantly sign in and start using them. And then what are some of our benefits? Of course, there's cost benefits. The pay as you go model being one of the number one reasons that we want to do this. You start a server, you pay for it, you determine you don't need to use it anymore, you can shut it down and cease to pay for it right away. And then, of course, what are some of the risks? We'll be talking about that. A lot of the risks are security related, access related. You're putting your workloads in somebody else's hands. But these cloud providers are really good, and if we architect our solutions in a way, we're not really putting ourselves in a great deal of risk as long as we ensure that we create a cloud design that will recover after failure. So again, all concepts that we're going to explore more deep. So go ahead and hit pause and read the networking, a quick primer starting on page 36. All right, so this section starts out talking about maybe you know the intricate details of how information gets from point A to point B, or maybe you've never given it a second thought. Um, I've taken a lot of courses in networking and I definitely understand how it works, but I will be perfectly honest and say I'm one of the people that doesn't worry too much about it because I have really good people on the team that ensure that all of the networking components work and that everything is secured and locked down. I always like to point out if this is something that you have a lot of interest in, look into it. There are lots and lots of positions and great opportunities for people that are really into networking. I just never really have been one of them. I enjoy playing around with things, at a local level. I like to play with. I have cameras that point outside from inside my house. I connect things to I have all of my TVs that connect into my home network. And so there are certain things about the networking that I do enjoy, but when it comes to corporate networking, that's a different story. But that being said, I always like to point out that there's lots of good opportunities. I know I appreciate you guys on my teams that ensure that all of the networking components are taken care of. So anyway, when we jump into this, we should first of all say, what is a network? So a network, easily defined, two or more devices can communicate with each other. This requires software, so you have to have a network client, it's usually built into the operating system. Didn't used to be. Back when I was first getting into it, you had to have Novel NetWare and you had to install that separately on a computer because, believe it or not, we had computers that may or may not have internet connection and may not be connected to anything except for a printer. Might be the only thing that we would even connect it to. But of course, nowadays, almost every device that you purchase has some kind of networking built in. But besides the software and then, of course, the hardware, we had to have our network adapter, our network card, and we also have to have a defined transmission method or a network protocol. So, again, this nowadays, we're not as concerned about this because almost every device has some way to be networked. I mean, heck, even garage door nowadays have a networking component that you can interface with. But of the devices that we are connecting to, and as we're thinking about cloud, of course, we have our network interface card. We also, we know that we can connect things via Ethernet, but then now we're also used to a lot of devices having a cellular or a Bluetooth layer. So first of all, I want to be clear. You don't need to understand this level of detail when we're talking about networking for this exam, but it's still a really good idea to start broadening your horizons and understand a few little pieces of this. So throughout the history of computers, there's been lots and lots of different protocols, but we've kind of let a lot of those go by the wayside. And the ones that have really won out and that have been around the longest and the ones that people use is the TCP IP protocol. So there's several different layers, and each layer is responsible for a different part of what is required. So if you look at figure 2.1, we'll see that our network access, this can be an Ethernet cable or a Wi-Fi. These are the things that we're used to seeing and how we connect things in just to plug them into the router. And then, of course, when we talk about our internet, we start talking about the IP, and we'll talk more about IPv4 and IPv6 later on. And that does come into play, especially when we start creating virtual machines. So you do have to have a little bit more of an understanding of that layer. And then we have our host to host. And so we'll talk about the transmission control protocol. And so this is kind of the piece that's out there that makes the two devices talk to each other, that's out beyond the internet. And then whenever we talk about our process applications, these take on a couple of different things. We're used to talking about things like HTTP. And then if you're doing file movement, you might learn a little bit more about FTP. And then, of course, when we're talking about HTTP, we'll also talk about the HTTPS, which is the secured layer. So just again, just a very high level overview of what this protocol suite looks like. So the next 5 sections that we're going to go through, we're going to talk about how using Hypertext Transfer Protocol Secure, which is the HTTPS with the S on the end of it. Then we're also going to talk about using Remote Desktop Protocol, and then using Secure Shell or SSH, using Virtual Private Network, and using Direct Connect. Now, some of these you probably already know about. We're going to review them quickly, and then a couple of these might be the first time you've ever heard about this, unless you've already been working in the cloud. So first of all, connecting to the cloud using the Hypertext Protocol Secure. Remember, if you're on a website, you want to make sure that you do see that S. That ensures that you are in a secure layer. So what this is your web browser goes to this site, and it has many users that are connecting individually. And then that S ensures that your data is encrypted in transit. So we'll be talking more about encryption at rest and encryption in transit as we get into the storage part of this chapter at the end. And then the next thing we want to look at here is using remote desktop protocol. So once you go out and you create a virtual machine out in the cloud, you want to access that. You do not want to access that through your cloud tool. The tool that you created it in, you can sign into it and do some things from there. But you, of course, want to sign into that server like it's its own device, like it's completely separated from your cloud deployment. So we'll sign into it using a remote desktop protocol. Now, if you've never done this before, we can do this inside, like one of us could open up our desktop and let other people sign in and access that desktop directly from there. Very, very similar to what we're doing here in the cloud. So after you create the virtual machine, you can connect to it, and then you sign into that server, and you can do things with it from your data center, your home, or your office. There are many uses, including extra server capacity, test software on multiple operating system platforms, creating test environments. And so you connect using RDP, Remote Desktop Protocol. And I'll tell you, I do this even with my own personal devices. I can sign into my work machines, or from my work machines, I can sign into different servers. And I do this quite often. As a matter of fact, right now, I'm signing into 2 different desktops from my personal device because I'm waiting on a new laptop to be shipped to me. And honestly, after I'm working on it for a few minutes, I kind of forget that I'm not working on a desktop that's at my desk. So it really works nicely. So if you haven't had a chance to do this yet, you will, and we'll be talking about this more. So this is what it looks like if you're connecting from one Windows machine to another Windows machine. That machine could be sitting in a cube next to you in an office down in another part of the building, or it could be completely across town or across the world. You remote desktop into that connection. So we also have situations where we're doing a lot of virtual desktops, and we'll learn more about VDIs and virtual desktops later in the course. But this is a service that is provided by people like Microsoft and Citrix, and it's a way to create a virtual image so that you can sign into it, and it looks like you're connecting to a Windows machine. These are really, really popular now, mainly because people, companies that want to hire a bunch of extra help or temporary workforce, they hate to send out laptops and then have to collect laptops back in. It's a lot of work. And then also you have these physical devices that you have to maintain. And at the end of their life, you have to dispose of. But if you use a VDI, you could hire a bunch of temporary people, create these virtual desktop images for them, have them sign in, do the work, and then when you come to a time where you no longer need this temporary workforce, you can just remove the desktop, and there's nothing to take care of. So lots of good use cases for why we do this. So then another way that we can do this is using a secure key pair. This has a lot more to do with Unix and Linux, but there's a video here in the slides. If you click on this, you're going to get a chance to see what it's like to sign into an AWS virtual machine, and it looks like it's directly from your machine. As a matter of fact, you start out at the command prompt, you create the pair, and when you do, you can access the cloud environment directly from your machine. And then also, when we're talking about this, kind of a very similar thing where we have our secure shell. And this is when you're doing Linux or Unix and you're signing into that machine. And so you're using a Windows machine to sign into that. So we have to have the secure shell in order to make that work. And then you can run your commands from a command prompt. And again, if you watch that video from the last slide, you've seen that work. You can sign in to another environment from your machine. You can do things like list out what is in your storage and various things. And there's when you're looking at the command line interface, there's nothing that you can't do from the command line interface that you can do from the environment once you're signed in. So we'll talk more about that. But there are actually a few things that you can do from command line that you cannot do from the inside of the cloud tools. So again, we'll talk about that more. And then also PuTTY is a tool. If you haven't used it, it's a way for you to have something running on your Windows machine where it allows you to sign into a Unix or Linux machine and interface with that machine from there. Now, as we progress through the chapter, if you look at figure 2.8, we're going to be talking about what a virtual private network is, or a VPN. So usually when you create a cloud environment, you start out with exactly one VPN, and then you can create sub VPNs on that, or subnets. And so we'll talk about that more as we get more into the chapter. But the definition here of a VPN is it's a secure private network connection that occurs through a public network. So VPNs can be used to connect individual users to a corporate network or server, or connect to a company's network or clouds together across internet or other public networks. So it's a point-to-point connection, has a secure tunnel. Even though it is through the internet, it's a secured channel. There's no chance of somebody being able to break into that. You're establishing a connection, and by use of passwords and good network protocols, I'm not saying never. There's always a chance of somebody hacking in, but it's very, very difficult in order to break into that actual VPN tunnel. Once this machine makes a connection to this machine, very secured broadband connection, tunnel, and then you also have your router over here. So this is your corporate network. This is somebody outside of the network that's accessing machines that are inside that network. And finally, we'll talk about direct connect. So there are a couple of different ones of these, and they are associated with our larger cloud service providers. So a connect direct, or direct connect, provides a physical connection between your company's on-prem and the CSP. So this is the data center that you own, that you control, and you sign in to the CSP. And it's not going over the internet. It is a direct connection. It's a separate connection, one that you're paying for. It's a telephony solution that you go out and you have it set directly up. So when we look into these, when we're wrapping up these chapters, I have some great documents that will help you remember and be able to easily see the different products, and the ones that are for Azure, and the ones that are for AWS, and the ones that are for GCP, but line up to what their function is. Because at the end of the day, we're performing network functions. None of these CSPs own the architecture or the thoughts behind how these things are established, but they do have different products. And the way they set up their products is making this work in the same way that it would if you were going data center to data center. So the Azure product is called ExpressRoute. The AWS product is called Direct Connect. And then the GCP is called Google Cloud Interconnect. And we've talked about this a time or two, or at least I've mentioned it, that when we think about replacing our data centers and moving into the cloud, we got the big four things. We think about compute, storage, networking, and then databases and other services. And so everything that's in those services, there are lots and lots of services. So we'll talk about these going forward, but they have services to try to replace just about everything that you need to do with your physical work. And the reason this is because we've taken a step of moving the IT industry into the cloud. And once you're in the cloud, the next logical step is look for ways that you can perform things using services instead of servers. And that way you don't have to keep a server up and running. You don't have to keep the operating system up and running. So these services are getting better and better. And I can't wait to see where we're going as an industry, because we already are running things on fewer servers than we used to have to. We definitely are not running great big servers like we used to. We're running smaller servers that we try to have them running at about 90-95% capacity. And then if we start getting too high, then we will create another server and take some of that workload off. And the reason that we're doing this is because we're paying as you go. You don't want to spin up two servers if one server is good enough. So as I'm saying this, I'm saying we're already lowering the size of servers we have. We're lowering the need to have servers running. And now we're adding on this other thing, this service mindset, to where we no longer have to even think about what the server is. We're going to run it on run a service, and that service can run on some server that we never need to know anything about. Amazon's maintaining that for us. Microsoft, Google, Oracle, they're maintaining those servers. So that's kind of where we're going in this cloud world, is going from our data centers to paying somebody else to run our data centers to eventually finding a better way to run all of our services. So I just talked about the concept of running a server, and instead of thinking I'm going to run a server and I hope I only use about 30% of it, now we go in with the mindset, oh, I'm going to put a server out there and I hope to be running at about 95%. If I'm not running at 90-95%, that means I have over provisioned the resources. I am wasting money that I don't need to waste. So one of the things that helps make this work is one of our major networking components. So load balancing is not a new concept. We've been running load balancers for years. As a matter of fact, we used to order things directly from some of these companies like Brocade, F2, I think it's F2, and there's different products, and we would order the equipment, put it in our data center, and its job was to balance load. So if you look over here at figure 2.12, you can see you have an incoming request, and then you have this load balancer. And that load balancer determines where to send that load. Now, some early load balancers I remember seeing back when I first introduced to this, like nearly 20 years ago, we would just do something where we would just throw the first user over here and the second user to the next server and the third user to the next server, and then just keep running that around so that we could balance the load. But load balancers are way more advanced now, because what this load balancer does, now in this diagram here, we're talking about this physical looking piece of equipment. But when we're in the cloud world, it's no longer a physical piece of equipment. It's a network element that we provision and put into our cloud environment. And it's smarter than the older load balancers. It knows how this machine is running. It knows how this machine is running. So when the request comes in, it will say, inside, it will say, okay, this is the least hit server. Let's throw it over here, boom. And it will run that user there. If something happens to this server and it's taken out, the load balancer is the piece that knows, okay, pull everything, don't send any more traffic there, take that completely out of commission, only send things to these servers. And that load balancer is also the thing that is smart enough to send a message that says, after I've used up too much of these servers, I need to spin up another server. So we'll talk about these. These are also scaling actions. They occur inside the cloud service provider. But in this networking chapter, the part I'm wanting to focus on here is one of the networking elements that is a really major part of cloud is that load balancer. So we have a couple of videos here that if you want to take time to click on and watch, you can. And I would definitely recommend it. One of the videos is about what is a load balancer. It's just a very generic one. And then we have Amazon Web Services load balancing, which is a really good example of how these things work with good graphics. And it's a great way to help you remember the functionality of these. So some of the benefits here: performance, scalability, and reliability. The next networking element that we want to discuss here is cloud networking. And within our cloud networking services is our domain name system, our DNS system. So I have a couple of videos here if you want to go out here and watch, but simply put, a DNS system or domain name system, it returns a value. So again, I'm very, very simplified, but this really is its full function. If I plug in an IP address and I type it in, it's going to return to me the friendly name of a server or a system. Or the opposite of that, if I type in the name of a system, it's going to bring back the IP address that I'm supposed to go to for that. So for instance, I sign into a web browser and I type google.com. Well, that is going to go out and it's going to bring back an IP address of a server where it is going to send me. Now, all of this is invisible to the user, but it's a way that the networking component, instead of you remembering what an IP address is and typing in 1.44.256. Instead of typing out that IP address, you are just putting in a friendly name and it's bringing you back that. So with that simple definition, you can imagine how important it is for our systems to have these domain name systems. Now, this also works like if you're inside of a company VPN. Let's say that you have a timesheet that you have to fill out, and the name of the application is timesheet. You type in timesheet, and it brings up the application. Well, what it's really doing in the background is that web interface is picking up what you typed, sending it to your DNS server, pulling back the IP address, and putting it out there for you to go to that IP address. So now think about this concept as well. If you're in the middle of a disaster recovery issue, or you're in the middle of a DR and you've implemented a disaster recovery plan, this is one of the places, your DNS is where you can go out and make a change so that now, instead of going to this one place, whenever somebody types something in, you make the change and now it's going to return a different value. So this person is going to go to a different place or a different internet protocol, a different IP. So that is the reason that this is in the networking chapter, and is a very, very important component of what we can do with our networking elements. So then some of the different CSP solutions, again, every one of the CSPs has a different name for this, and they actually perform slightly different functions depending on what they do, but at a bare minimum, they perform the function of domain system. So you have AWS, which is Route 53, Azure, which is Azure Traffic Manager, and then Google has one called Google Cloud DNS. Another network element that we're all used to talking about, and we understand the concept, it's same thing in cloud. We have firewalls. So you have your internet and you have the firewall. And essentially what the firewall does is it blocks all traffic until you poke a hole in the firewall. So you give it a range of IPs that you're going to allow. And so you have your internal network, your web and email servers, and then the internet, and the firewall determines what traffic it's going to allow and what traffic it is not going to allow. So firewalls have a hardware and or software solution. Most of them today are probably running as a software solution. There are network element physical servers that you can put in that are firewalls, but I would say that most of those have probably gone away through the years, and we're really looking more at a software type of solution. And then we also have our network security guard and our DMZ. So when you see DMZ, that's a military term. It's called demilitarized zone. And so what this is it's a zone that you absolutely won't let anything bad happen to. Same thing in the military. The DMZ is the area that's most heavily guarded. You have guns, guards, tanks protecting that. Same thing in IT. That's just they've kind of taken that term, and so we have our DMZ out here, and it is behind the firewall. So you have your internet, and you have to know exactly how to get through that firewall to get to your DMZ. Okay, so now we have talked all the way through our network part of the chapter. And now we're going to move more into the storage side. They're somewhat related, but really and truly two completely different um, subjects. And so now we're moving into we have to have our networking solution in order for our storage solutions to work. But as we move into this, we're now going to really focus just on the storage side. So if we were together, I'd have a classroom conversation, but I'm just going to ask the same thing that I would ask to a classroom. Think about what storage options you use. We have Dropbox, Amazon Drive, OneDrive, Google Drive, iCloud. I believe the very first solution I ever used, it is still out there, and it was called Carbonite. And it was a really good solution. And it was one of the first ones. And it was one of the first, they did the best job of marketing. A lot of people jumped out there and used it. But through the years, I still see it's around. I see ads for it every once in a while. But really, these other guys have taken over, and they kind of own that storage market. So if you think about what storage you use, I'll tell you that I use Dropbox for certain types of data. For instance, I like to use Dropbox for whenever I take pictures, they all get uploaded to Dropbox. And the thing I like about Dropbox is it won't do anything to the file. It just saves the file as is. It will never do anything to shrink the size of the file or the quality of the file. So that is a solution that I like for that. I've never actually used Amazon Drive other than S3 inside of an AWS environment. So we'll refer to that later. OneDrive, I use OneDrive a lot. As a matter of fact, I use Office 365 for a lot of my solutions. One thing I like about it, and I think if you've used it, you would as well. There was a period of time where I was using a Chromebook exclusively, and I went ahead and paid for that Office 365 environment so that I could have access to online Excel, online Word, online PowerPoint, and I could save my files. I no longer just use a Chromebook, but I still like the solution and continue to use that solution. Um, it's a great place to store a lot of your files. It's not overly expensive, and you can get to it from anywhere. Google Drive, same thing. At one time before I moved into OneDrive, I was exclusively Google Drive. And I don't know, sometimes I consider it going back because it will still sync to your desktop. It will do all of the things that you need it to do. And it's again, not very expensive. And then you have your iCloud. I know a lot of iPhone users and Mac users like the iCloud. I don't, because I also use a lot of things that are not Mac driven. But the things I've seen with iCloud, it works just as good as the others, but you are kind of tied into that Mac world. So anyway, if you would just kind of think through these, if you haven't used any, that's fine. I would say the best one to jump into if you haven't used one at all is Google Drive. Just go in, get you a Gmail account, and then go up. I think we talked about this in the first chapter. Go up to the upper right hand, click on the applications, go to your Google Drive, and then boom, you now have drive space out in the cloud that you can access from anywhere. Now that you've started studying cloud and studying these concepts, you're no longer just thinking of it as an end user. So we just talked through what kind of storage solutions you have. Now let's dig a little bit deeper and think about this. So take a look at figure 2.15. This is software-defined storage. So this is taking a physical storage of data and separating it from the logical control over that data. So what this means is, let's take a look here at our storage volumes. You have server 1, server 2, server 3. These are actually different types of storage, but for our example, these are running here. As a matter of fact, let's look at storage volume 1, storage volume 2. We have SSD1, which is solid state drive 1. So everything that I store here is being replicated and it's placed over here. Now, the reason we would do this is because if something were to happen to this group of servers, our data is still secure. It is over here. It's been kept up to date at all times. So if you're using a solution like Google Drive, OneDrive, your data is not really in just one place. Your data is probably in a minimum of 3 places. Because if anything happens, if the drive fails, the computer running it fails, you as the end user never need to know that there was any kind of a problem. You just need to know that your data is there and you don't have to worry about it. It's always being backed up. It's never going to get confused. And it's because the software defined storage, this piece here is the one that is handling the control and the logical configuration of where that drive is. But like I said, now that you're exploring this and you know this, you know that your data is not just in one place. Your data is in multiple places being replicated at all times. But whenever you look at it, it looks like it's a drive that's sitting out there that has everything on it. Our software defined storage should have the following features: scalability, transparency, standard interface, storage type support. So first of all, scalability, grow as much as needed. So both the amount of storage offered to the client and the underlying hardware should be scalable without any performance issues or downtime. Then transparency, how much storage and how much will it cost? So transparency, administrators and clients should know exactly how much storage is and available at what the cost of storage is. Now, when we start going into the cost of storage, you're going to see exactly how cheap storage is, and you're going to stop and say, wait a minute, if storage is so cheap, if I'm paying pennies for the gigabyte per month, how come I'm paying so much more um, when I'm going to one of these providers? Well, you're paying for the service, you're paying for the backup, you're not just paying for where it is. So when we go through that, you're going to see that a gigabyte of storage is less than a penny a month, and but there's a reason that we use these tools, and even when you're when you're in the cloud and you're designing systems, even though it's that cheap, what they're paying for is all of the extra work that you're putting into it to make sure that it is backed up, make sure it's available, and all of those parts. And then the standard interface, it's easy for admins and clients. So it should be easy for the people that are taking care of the environment to understand what they need to do to manage that. And then finally, the storage type for support, objects, file, and block. We're going to go through each of these in great detail, but in short, object level storage, the way to think about object level is it's a one object that you're placing out there in a storage bucket. And then file storage, this is more like what we're used to when we're running a Windows environment and we're storing things in directories. And then block level storage, we'll go into a little more detail on block level storage, but one of the key features of that is if you're backing them up, everything's in a block and it knows if a block changed or not. So when you're backing things up at the end of the day, if the block changed, it'll back up the entire block. If it knows the block did not change, saves you lots of time and effort when you're managing backups. So each of the cloud-based storage providers has features that matter to people, and then price points that could also be a factor of things that people are thinking about. So here on this slide, this isn't in your book. This is something that I just went out and grabbed. It shows all of the strengths, weaknesses, and what you get for the money, and then also the personal versus business use. So it's just, you don't need to memorize these by any means for the exam, but if you're looking for one good place to come find this information, I thought that this put it together pretty good. But if you look through your book and as you're reading through this chapter, you're going to see it's got some price points and how much you get for what. So, for instance, Dropbox, you can get 2 GB for free, but then if you want to pay for it, you'll pay for a terabyte, you'll pay about $99 a year. And then with Apple iCloud, you get 5 GB for free. Everybody that has an iPhone probably already knows these numbers. And then as you get bigger, you can get like up to 2 TB for about $120. And then Microsoft OneDrive, you get 5 GB for free, but then you can either get 50 GB or 1 TB for $24 or $70. And then Google Drive, you get 15 GB for free. That's the most that anybody gives you for free. And then the premium, they have different tiers. So for 100 GB, you get for $24, a terabyte for $120, or for 10 TB, you could pay up to $1,200 a month. But I mean, 10 TB is a lot of space. So again, feel free to hit pause, look at this slide. You also have the slides at your disposal so you can look at it. Just one place to look for all this information. Next, we'll focus on our cloud storage. So some cloud some storage characteristics. So with Azure, they have premium, hot, cool, archive tiers. With Google, they refer to it as multi-regional or regional, which is hot, and then nearline and codeline, which is cold. And then with AWS, they have some very specialized storage. And so they have one that's called S3, Simple Storage Service. Simple Storage Service is storage for the internet and it's object level. So if you have something that's an object is anything that's like one file. So you could take picture files, every one of the pictures is an object. Music files, every one of the songs is a different object. And so S3 is a really great storage option for that. And then AWS also has Glacier for long-term archival of data. And so everybody, all the CSPs have slightly different ways that they solve the problem. They'll all do the same thing. I mean, of course, you just work out how you do it. But each of the CSPs have their own tools and their own way to handle storage. So some of that, here's, if you look at table 2.3, the hot versus cold storage performance. So the trait like access frequency, so hot is frequent, cold is infrequent. Access speed, hot is fast, cold is slow. Media type, so fast hard drives such as solid state drives, slower hard drives such as conventional hard drives. And yes, you can buy cloud versions of conventional hard drives, but they're kind of getting smaller and smaller. People are determining it's not really worth it. Kind of like the same way when you go buy a computer. A few years ago, solid state was so much more expensive than a spinning disk. You probably might make a decision to get a really small solid state drive. But once people get exposed to it, they say, you know what, the cost is worth it. Plus, the cost is coming down. And so, I really think that we'll be all solid state drive probably within the next decade. Don't quote me on that, but even though there's still some use cases where people prefer hard drives and spinning drives, and they'll pay less for it. There's other options in the cloud, so we'll see what happens. But my money is that those disks are going away and solid state's going to be taking over. And then your cost per gigabyte, higher kind of aligns with hot, lower aligns with cold. As promised in the opening slides, I told you that we'd learn just a little bit more about this. So file storage is like a filing cabinet. So Windows uses the new technology, or the NTFS file system. Macs use Apple file system, APFS, and then Linux uses 4 extended file systems, which is the ext4. So what we're used to seeing, like in a Windows environment, you can go in and see your file system. There's some small differences in the way Windows does it and Unix does it. For one thing, when you're looking at a Windows machine, you might be looking at the hard drive, but I think we're getting more used to looking at a OneDrive, which is completely separate. So it's a file system that's outside of that computer. And then also with a Unix and Linux system, there's a slash between them. And then when you're looking at our an interface like this here, you don't see the slash, but you do know that if you sign into a command prompt, you're going to see the slash between the folders and the file names. And then block storage. So block storage is chunks of data. And as I kind of mentioned, one of the best reasons that you go with block storage is here are the blocks 0, 1, 2, 3, 4, 5, 6, all the way through 41. And when you're backing these up at the end of the day, you're using this. This is your hard drive. But it looks through and it says which ones of these changed. Well, if you have an application that's got more read data than update data, it's not going to have a lot of things that change. So at the end of the day, instead of backing up this entire drive, it's going to say which of these blocks changed. And let's say only 2 of them changed. Then back up those 2 blocks. And if you ever have to do a full backup, we have solutions in place where you run the backup and it will bring in the main backup and then all the blocks that changed. And it doesn't look any different to you, except it's much, much faster and also a lot cheaper. Now, we've already talked about object level storage just a little bit. Let's go a little bit more in depth here. So object storage is for things like pictures, videos, files, Word docs, Excel files. Anything that is a file on your computer can be considered an object. So what's great about the object level storage solutions out there is it's called storage for the internet. It's object level storage. So you can save these files out here in buckets, and you can set permissions up so that anybody can access them. They're great. They're easy for retrieval. The data is the file itself, the metadata, which is, if you don't know the definition of metadata, metadata is data about data. And then the attributes, so the classifications, and then your ID, which is a unique ID. So think about many different use cases. I mean, there's thousands and thousands of use cases of why you would want to use object level storage. But let's just pick one and say that we have a music site. So every piece of music is available to anybody that is subscribed to your service. And in some cases, we allow them to just click on the music and listen to the music. In other cases, we allow them to click on the music and download the music. So this is a good example because I'm showing you choose the access in which people can get to the object. You might not want anybody to have access to the object until they pay for the service. And then through that service and through their sign in and their user ID, they would only have access to do whatever you want to allow them to do with that storage. A few other features here when we talk about our storage. So compression. So compression has to do with how we make the files smaller so they take up less space. Deduplication, file level or block level, eliminating duplicate data. And then capacity on demand. So you don't prepay for storage, you only pay for what you need. So the good thing about storage, let's say, back in the day, we're going to order a bunch of drives. We have to pay for the entire drive. We install them in our data center. We pay for them whether we use them or not. Well, with storage, you only pay for what you use, which is great, but not like a server. You know, a server, we can shut down and cease to pay anything. If you put stuff in storage, you of course are going to pay for the level of storage of what is out there. So think about that as you're kind of pulling these thoughts in and collecting your thoughts on cloud and what it means. You still only pay for what you need, but it's not like a server or something out there where you can shut it down and pay nothing. Once you're consuming it, you're going to pay for it. But there's also different levels of storage. We kind of touched on some of this earlier in the chapter. But we pay for how much we want to retrieve the data. We also have archival options so that we can archive data, and we would only pay more for the data if we pull it back and need to use it. So various use cases there as well. And then the next thing we want to talk about here are content delivery networks. Content delivery networks are really a very cool thing that came out of the cloud. So with a content delivery network, before I go into the details of this, let me kind of explain this to you if you haven't heard of it before. So let's say that we have this server right here, and we want to deliver content to all of these different continents. And the reason we want to do this is because somebody over in this continent doesn't want to go all the way back over here for the data. They don't want to wait seconds for it to come back. So you deliver your content to various locations out here. These various locations are called edge locations. You just kind of need to memorize what that means. So it's an edge location. And so the great thing here is you dump this data out here. You don't have to duplicate it. It's duplicated all back here where the origin is, but you dump the data out here once. So think of it like a newspaper, and you're putting your content out here. Now everybody in this continent or this area can come in here and get to that content. And then if something were to happen to this, no big deal. You just put it out there again. And it's a one direction. And again, just this is a content delivery network, and something that really, I mean, we had content delivery networks, but when we added the cloud functionality to it, just made it work that much better. So things to remember in a content delivery network: you create a point of presence right here, the pop, and then you increase web performance, faster load times, increase reliability, decrease bandwidth cost, greater scalability, and increased security. Now, I gave you a really quick, easy thought of this being one directional. That was to introduce the subject. There's something else that you can do with these edge locations. Let's say that I have somebody that's uploading data. If you write the correct type of solution, this user could be uploading data here, and it goes back to the source and gets fed back out. So this is a really fascinating thought. I have a series of work that I do where I put a bunch of really large files out in this. I have to store them on my side using OneDrive, and then I have to put them somewhere else for the customer to be able to see. Well, the place where I'm putting it where the customer is, it's a solution that has an edge location. So even though most of my customers are in Washington, D.C., I'm out here in Kansas City. And on that once a month, when I'm uploading those files, I'm moving them inside my own virtual private network, and they take about 30 minutes to move. When I am placing them out in the edge location, let's say I'm this guy right here, when I throw these files out here, it takes about 3 minutes for me to throw those files there. And then it cranks away on that server for a long time to go up here. But to me, the user, it looks like all of that work took place in 3 minutes because I'm done. I can shut my computer down. It's already uploaded the files here. But then it has to be smart enough to go up here, put it back into the original, and then redeploy it out to all of the edge locations. Okay, so we wrapped up chapter 2, and in chapter 2, we talked about networking and storage. So we mainly focused on the networking services, including software defined networking, load balancing, firewalls, other network elements that are included in that. And then we spent the last half of the class talking about cloud storage. So we have software defined storage. We talked about providers and plans. We talked about the different storage types like file, block, and object. And then we also talked about the storage features like compression, duplication, and capacity on demand. And then we wrapped up this chapter talking about our content delivery networks, or CDNs, and edge locations. Hey, just a reminder on the exam essentials. If you would rather just read through these I'm going to go through the same ones that are in the back of your book, but I'm going to add a little bit of commentary in here and give you any tips and tricks I can help you for the exam along the way. Okay, so these are: know how to connect to a cloud with HTTPS. So Hypertext Transfer Protocol Secure is used by web browsers such as Google, Chrome, Microsoft Edge, Apple, Safari to connect to a URL to a cloud resource. And remember, you look for the S at the end in that HTTPS, and then you know that you're using the secure. Know what RDP is used for. So remote desktop protocol is used to connect to a remote Windows-based server. So remember, we have to do other things for Linux, but for Windows, we can connect from one Windows machine to another using RDP. Know how to connect to a cloud with HTTPS. Oh, that's a repeat. Let's see. Yes, that's a repeat of the one we just had, so don't worry about that. I don't know why I have two of these repeated. Just go ahead and delete that. Know what SSH is used for? Secure Shell is used to connect to a remote Linux-based server. Understand how VPNs are used. A virtual private network is a secure tunnel through an unsecured network, such as the internet. So VPNs can be used to connect as an individual user to a cloud server, and they can also be used to connect to a corporate site or one corporate site to another. Know when direct connect should be used. So if a company needs to make extensive use of cloud services and have very little delay, the direct connect between that company's network and the CSP's network might be the best option. So remember, direct connect is a solution that you purchase to connect your data center directly to the cloud service provider. Know which connectivity methods are secure. So HTTPS, RDP, SSH, VPN all have built-in encryption. A direct connection should be secure as well, provided it's configured properly. Understand what SDN is. So in software-defined networking, the physical routing of packets is separate from the logical control where the packets should be routed. So an SDN provides flexibility and scalability for corporate networks in the cloud. Know what a load balancer does. So this is one of those network elements that's unique to cloud, or it's not unique to cloud, but much easier to use in a cloud world. So load balancing is a set of servers configured to perform the same task. They can speed up networking performance by sending tasks to the server that has the most capacity. Understand what DNS does. So domain naming system resolves host names to IP addresses. So it does a little bit more than this, but just think of it as just a way for you to put an IP address and it will bring back a friendly name, or put a friendly name and bring back an IP address. And so a friendly name would be something like google.com, yahoo.com, and you go out and it actually returns an IP address for what it wants you to use. Understand what a firewall does. So a firewall is a security device that protects computers or networks from malicious network traffic. Know what file compression is. So file compression makes files smaller to take up less room when they are stored. It works by looking for repeated words or phrases within a file and replacing them with a shortened version. Understand the difference between file compression and deduplication. File compression works within a file. Deduplication works between files. For example, if there are 10 copies of a Word document, a deduplicated file system will store only one copy of it and replace the others with pointers to the original file. Know what capacity on demand is. Capacity on demand clients can get more storage space from their CSP nearly instantly. Understand hot versus cold storage and the performance implication of each. So hot storage is online and always accessible. Cold storage may be offline on tapes. Hot is more expensive per gigabyte, but the performance is much faster. Understand when to use file, block, or object storage. So file storage is used on personal computers and many servers and works best for smaller storage solutions. Block storage is best suited for databases and large-scale, frequently accessed storage solutions, such as those found in SAN. So object storage is great for unstructured big data and for large computer or network backups. Know what SSD or SDS is. With software-defined storage, the physical storage medium is abstracted from the user and controlled by the central server. This allows storage volumes to span physical devices, many storage volumes to be held within one physical device. To understand a CDN, so a content delivery network, is a load balancer for web-based content. Edge servers in remote location service users who are closer in proximity to them than they are to the original web server. So remember, a content delivery network, you have edge locations out there. There are a bunch of little data centers that are out that all they do is receive information and put that information closer to your customer. So several use cases for that. Let's just say like Netflix. Netflix might be in one location, but they of course are not going to keep all of their movies in one location and have all that traffic going across the country. So they may move their content, and in their case, their movies, to sites in every large city in the country. And then that way, when you're selecting it and you order a movie, it's not going to make you go all the way across the US. It's going to go to the closest location in order to retrieve that. Same thing with newspapers and other content. So content delivery networks are kind of a fascinating thing and a really good use case for people moving things to the cloud. Hey, just a reminder on the exam essentials. If you would rather just read through these I'm going to go through the same ones that are in the back of your book, but I'm going to add a little bit of commentary in here and give you any tips and tricks I can help you for the exam along the way. Okay, so these are know how to connect to a cloud with HTTPS. So Hypertext Transfer Protocol Secure is used by web browsers such as Google, Chrome, Microsoft Edge, Apple, Safari to connect to a URL to a cloud resource. And remember, you look for the S at the end in that HTTPS, and then you know that you're using the secure. Know what RDP is used for. So remote desktop protocol is used to connect to a remote Windows-based server. So remember, we have to do other things for Linux, but for Windows, we can connect from one Windows machine to another using RDP. Know what SSH is used for. Secure Shell is used to connect to a remote Linux-based server. Understand how VPNs are used. A virtual private network is a secure tunnel through an unsecured network, such as the internet. So VPNs can be used to connect as an individual user to a cloud server, and they can also be used to connect to a corporate site or one corporate site to another. Know when Direct Connect should be used. So if a company needs to make extensive use of cloud services and have very little delay, the Direct Connect between that company's network and the CSP's network might be the best option. So remember, Direct Connect is a solution that you purchase to connect your data center directly to the cloud service provider. Know which connectivity methods are secure. So HTTPS, RDP, SSH, VPN all have built-in encryption. A direct connection should be secure as well, provided it's configured properly. Understand what SDN is. So in software-defined networking, the physical routing of packets is separate from the logical control where the packet should be routed. So an SDN provides flexibility and scalability for corporate networks in the cloud. Know what a load balancer does. So this is one of those network elements that's unique to cloud, or it's not unique to cloud, but much easier to use in a cloud world. So load balancing is a set of servers configured to perform the same task. They can speed up networking performance by sending tasks to the server that has the most capacity. Understand what DNS does. So domain naming system resolves host names to IP addresses. So it does a little bit more than this, but just think of it as just a way for you to put an IP address and it will bring back a friendly name, or put a friendly name and bring back an IP address. And so a friendly name would be something like google.com, yahoo.com, and you go out and it actually returns an IP address for what it wants you to use. Understand what a firewall does. So a firewall is a security device that protects computers or networks from malicious network traffic. Know what file compression is. So file compression makes files smaller to take up less room when they are stored. It works by looking for repeated words or phrases within a file and replacing them with a shortened version. Understand the difference between file compression and deduplication. File compression works within a file. Deduplication works between files. For example, if there are 10 copies of a Word document, a deduplicated file system will store only one copy of it and replace the others with pointers to the original file. Know what capacity on demand is. Capacity on demand clients can get more storage space from their CSP nearly instantly. Understand hot versus cold storage and the performance implication of each. So hot storage is online and always accessible. Cold storage may be offline on tapes. Hot is more expensive per gigabyte, but the performance is much faster. Understand when to use file, block, or object storage. So file storage is used on personal computers and many servers and works best for smaller storage solutions. Block storage is best suited for databases and large-scale, frequently accessed storage solutions, such as those found in SAN. So object storage is great for unstructured big data and for large computer or network backups. Know what SSD or SDS is? With software-defined storage, the physical storage medium is abstracted from the user and controlled by the central server. This allows storage volumes to span physical devices, many storage volumes to be held within one physical device. Understand a CDN, so a content delivery network is a load balancer for web-based content. Edge servers in remote location service users who are closer in proximity to them than they are to the original web server. So remember, a content delivery network, you have edge locations out there. There are a bunch of little data centers that are out that all they do is receive information and put that information closer to your customer. So several use cases for that. Let's just say like Netflix. Netflix might be in one location, but they, of course, are not going to keep all of their movies in one location and have all that traffic going across the country. So they may move their content, and in their case, their movies, to sites in every large city in the country. And then that way, when you're selecting it and you order a movie, it's not going to make you go all the way across the US. It's going to go to the closest location in order to retrieve that. Same thing with newspapers and other content. So content delivery networks are kind of a fascinating thing and a really good use case for people moving things to the cloud. All right, I know we went through some of the chapter as we're going through this, that we've already read some of it, but now would be a good time to go back and reread the chapter, pages 35 through 76, making any highlights you need to, reviewing any of the information that you noted that you wanted to go back over, because we're about to start our written labs and then our test questions. And so this is a good way to know kind of where you stand. And don't worry, the first time you're going through this material, you shouldn't be acing it. I mean, it's not that easy. If it was that easy, everybody would be doing it. It's what we always say. So in this case, just go through, read the chapters, and then come back, and then we'll do the written lab and the questions, and you'll see where you stand. All right, so here on our written labs, again, I kind of like these. I almost like these better than the questions, because it ensures that you're not just picking the best answer. You actually have it in your mind and you're remembering what it is. So we'll just start up here at number one. A user wanting to log in remotely to log in and remotely manage a virtual instance of Windows Server 2019 would use the blank access type. This, of course, is RDP, or remote desktop type. Question two, the two methods used to securely connect many users at once to a cloud resources are blank and blank. So that answer is virtual private network and direct connect. Question three, a DNS server is responsible for what? It's responsible for resolving host names to an IP address. Remember, it's just kind of a little database out there that has host names versus an IP address, and whichever one you feed it, it brings you back the other one. Another thing to remember about that is if you are thinking about like a disaster recovery situation, you might see an exam question that says, hey, what is the most used thing? What's the first thing you use whenever you're in the middle of a disaster recovery? Well, this could be it. It might be your DNS, because you might be saying, instead of sending people to one server on one part of the country, you're going to send them to a server that's actually on another part of the country. All right, question four. Which cloud networking server functions as a security gateway? This would be the firewall. And then number five, Google Chrome connects to the cloud using, this is that Hypertext Transfer Protocol Secure, HTTPS. Number six, blank storage is the best type for large data backups. This would be object. So object storage is the best type for large data backups. There's lots of other reasons, and we'll get more into this as we talk about some of the specific tools. But yes, object storage is out there. Object storage is great. It's really easy to use, and a lot of people use it, and and that's one of the first things that they do when they go get into the cloud is take advantage of the object storage. But then with object storage, you can archive it. So you can put it into an archive and pay less. And so for long-term archiving, and those are different storage classes, which again, we'll talk about more later. All right, number 7, blank storage is less expensive per gigabyte than blank storage. Okay. You could actually fill these blanks in with several other things, but in our book, we're referring to this as cold and hot. And but when I see that question, one of the first ones I think of is solid state drive or spinning hard drive. But for this certification, the language that it's choosing to use is cold storage versus hot storage. And we talked about those words kind of having different, well, they don't have different meanings, but they refer to different types of storage. All right, number 8, to save space on a cloud storage volume, blank is used to remove multiple copies of the same file. This is deduplication. So that's a definition of something you need to know. Deduplication is used to remove multiple copies of the same file. Then number 9, blank, use a point of presence to locate servers near to potential users. This is your content delivery network, or CDN. Remember, this is where you use the edge locations to deliver content. So everything starts in one place, but you deliver it out to multiple places throughout the country, and it puts your content directly by your users. And then the last one here, Windows 10 natively uses the blank storage type. This would be file. So Windows 10 natively uses file storage type. All right, now we'll start our Chapter 2 review questions. Remember, if you would rather do this in the slides, or these are the same ones out of the book, and then also we have this in the slide deck so that you can go through this and do this yourself. So we'll do it here on video together, but like I say, just know that if you would rather do this on your own, you definitely have the capability to do that. So your company needs to upload a large offline backup archive to the new cloud service. What type of storage is best for this archive in the cloud? Well, in this case, it's object. So object level storage is a very simple storage. As a matter of fact, Amazon refers to it as simple storage service, SS3. And so object level storage is a way for you to store objects out there, but it also works great for backups. And the reason it works great for backups is you can take really large files, so you can zip up or tar up a bunch of backup files, and you can place them out there, and then you can put it into an archive view, which means you're going to pay a little bit less for the storage, and the only time you'd pay for it is if you needed to bring it out of archive and look at it. So lots and lots of details about object, but in this question, it's for sure object level storage. Number 2, the CSP is configured to access your cloud-hosted web server. Which of the following services will help users locate your web server on the internet? So in this case, this is DNS. This is that domain name system. It's what we've talked about. And I even mentioned the last part of in the written exam, or in the written lab, about how if you have a disaster, you might use the DNS to change that name in order so that when people go to a certain address, they'll come back into a different address, depending on what you put in there. Which of the following protocols is used with a web browser to securely access cloud storage? This is the HTTPS. Remember the S stands for secured. A network administrator needs to remotely log into cloud-based Linux server to perform some administrative task. Which access method should they use? Remember, we're talking Linux, so it's not RDP, it's SSH. Which of the following cloud storage types is designed to provide the fastest access to data and will be more expensive per gigabyte than other options? This is hot. So hot is available right now, and it's a little bit more expensive, but it's if you need to have access to it immediately, that's what you'd want to use. You're migrating to the cloud. Which solution would you use to handle spikes in the need for compute resources? This is load balancing, Which of the following technologies is used to create secure point-to-point tunnel connection to the internet? This would be your VPN, your virtual private network. The global sales team needs to ensure that all regional teams have quick access to the same selling material, including sizzle videos, PDFs with pricing. Which of the following should be used to implement this? This is CDN, the Content Delivery Network. And so what it's saying is that everyone out there needs to have access to this. You don't want them to have to cross the country to get that. You can put it out there in the edge locations and have it available to all of your users, or in this case, your users are your sales team. Your company is migrating its network storage to the cloud-based solution. Which of the following are most likely to be the least expensive storage options? Choose two. So the least expensive here would be cold and tape. I would say that in cloud world, really, there's no tape left. There are options that make it look like tape, but it's not really tape. It's just that we have systems that are so old that they're written in a way that it's wanting to put things to tape or magnetic storage. And so we have these cloud-based tools that make it look like tape, and it's still a fairly cheap option. So if you see the word magnetic or tape, just know that in the cloud, it's probably not really tape at all, but we kind of make it pretend that it is, so that you don't have to change anything in the application. Number 10, the cost for your cloud storage keeps growing, and you need to find ways to reduce those costs. Which of the following can help you do that? So we're going to choose two answers. Take a look at those. It's going to be the top two, compression and deduction. Deduplication, sorry, not deduction. Number 11, which cloud concept makes networks more agile by separating the forwarding of network packets from logical decision-making process? This would be that SDN. Number 12, your company just signed up with a new CSP and needs to upload a large customer information database to the cloud. Once it's uploaded, employees will continue to access the updated database. Which storage type is recommended for this? This would be your block level storage, block. 13, you're negotiating the cloud service with CSP. You need to ensure that your organization can get more storage space without CSP intervention. Which service do you need to use? This would be your capacity on demand. 14, which of the following technologies lets cloud provider create one logical storage volume from multiple physical storage devices? This is the SDS. Which cloud technology makes use of an edge server? Remember, this is CDN, Content Delivery Network. So usually the CSPs have the tool, and whichever CSP you're using the most, you want to remember three things together: the tool, then the content delivery network, and the edge server. Just remember that there's probably 35 to 40 availability zones with each CSP in the country, but there's 500 or 600 edge locations. So this is for content delivery, so that you can get your content out next to your customer. Your company has 500 users who need to access to cloud resources during all working hours. Due to the nature of their work, there can be little or no latency. Which connectivity type is the best choice? Remember, this is direct connect. This is connecting your data center directly to the cloud provider. You need to have multiple users connect simultaneously to cloud resources through a single connection. Which two options allow this type of configuration? Select two. Well, this would be, whoops, sorry, I went down too far. This would be your VPN and direct connect. 18, the network administrator tells you that you need to create a DMZ in the cloud. Which of the following cloud-based service will help you with this? So remember, DMZ is a demilitarized zone. It's the part of your database that you don't want anybody to be able to get to. And so you have to set up a firewall. Your company's in-house data center has a small storage area network that will be migrated to the cloud. Which of the following cloud storage types is most likely to resemble the way data is stored in the sand? This would be your block storage. So you're moving your company's network to the cloud. Network administrators want to know if they can still manage Linux and Windows-based servers. Which of the following are designed specifically for these tasks? This will be your SSH and RDP. Very good. That's all of our exam questions. Remember, you have access to these. You can go back in and go over these by hand. And anything that you don't know, I mean, that's what these are for. So if you don't understand the difference in the different types of storage, we'll talk through and we'll review these a little bit more, but go back and study your book and take down some notes. There's just a few things you have to remember about each of the storage types in order to do that. So that's why we're doing this. So great job. And we'll be getting ready for chapter 3.